Hi everybody, good morning. Today we're going to talk about intersection and union of common geometric figures. But let me start by reminding you about intersection and union just with these sets of numbers. Here I have the set of numbers 1, 3, 5, 7. And what about this symbol? This is the symbol for union. When we union two sets, we'll join them together. We're going to union 1, 3, 5, 7 with the set 2, 4, 6, 7. And I'll write the answer right there on the right-hand side. The union is I join the two sets together, so 1 must be in that union, 2 must be in that union, 3 from this one, and 4 is in that union, and 5, and 6. Now I'm trying to think about this. Should I write 7 twice? It does show up twice here, but the more I think about that, 7 is just a single element, and I should just write it once. So there's my answer right there. And I can put a nice little curly Q around it and say, there's my answer to that first one. Whoopsie, let me do that better. I can do that. But this symbol, well, this one was union, this one represents intersection. And the intersection, like the intersection of Broadway and 25th Street, is this part right here. The part that is both on Broadway and on 25th Street. That's the intersection. Well, what would be the intersection of these two sets? What's common to both? In this situation, the only thing that's common to both is 7. So there's the intersection of those two sets, just the number 7. And those are the things we've got to remember for right now using these two symbols.
Mr. Dickey,
Yes, dear.
can I put brackets, curly Q brackets around the 7?
Probably I should. That's a good idea. Why didn't I? I agree with you. Some nice little curly Q brackets right there. And therefore, there's the set with just the number 7. Now let's use this for points along the line for a moment. And play with this setup right here. As we do this, the first day of our geometry class, thinking about intersection and union. So Mr. Fisher, what's the first question, please?
The first question is ray BA,
Ray BA.
union with segment BC.
Now, I think I see this ray BA, which I know starts at B and goes through A, goes on forever. It goes to the left. So I'm guessing I should draw this arrow to the left? No, we're not going to do it like that. This ray starts at B and goes through A, and whenever you write a ray, you start at its endpoint, and then you have the arrow pointing to the right or the ray pointing to the right. So there's ray BA. And if the ray had gone vertically, we surely wouldn't want to name the ray like this. That would be kind of silly looking. Well, actually, if it pointed to the left, it would be as silly looking. Okay, ray BA, was it union, did you say, sir?
Yes.
Union,
Union segment BC.
segment BC. Let's think about what that must be. I'm going to join these two sets together. The ray that starts at B, goes through A, keeps on going. We'll join that together with the segment from starts at B and goes to C. It stops right there. Ah, what do you think? The thing that starts here and goes forever in that direction, we ought to call that ray CA. I'll write it just like that. This equals CA. Now, if you're doing your homework and you didn't make a copy, I would like you to write the questions, show the answer just like that. Make the sketch. Let's do another one. What's the next one, Mr. Fisher, please?
We have segment AC,
AC,
union with segment BE.
BE, just the segment both times, huh?
Yes.
Let me think about that for a minute. AC, starting at A, terminating at C. And BE, starting at B and terminating at E. And I want to join those two things together. I see there's something that is common to both of them, but I don't really care. All I know that this answer will be the thing that starts at A and terminates at E. So I ought to call that segment AE. Just like that. I believe it. They're invited if they would like to come in. Give me the third question, if you would, please, sir.
We have ray CA,
Ray CA.
union with ray CE.
CE?
Yes.
Let's see what that would do. Ray CA, starting at C, going through A, continuing forever. Ray CE, starting at C, going through E, going forever. What if I put those two things together? It looks like the whole darn line to me. Now, how could I name that line? A line is named by 2 points from that line. I like to use the outside points, but you don't have to. You can call it line BD, or line CE, or line AC, but I'm gonna call it line AE. To me, that's the best way. Although they're all really equivalent, I'm gonna call it line AE. But when I name a line, I gotta be careful. I gotta show that I'm talking about a line. Where these were rays, there's the line. That is the union of those two rays. What's the next question, Mr. Fisher?
Well, let's see here. We
The
have
fourth one?
segment BC,
Yes, sir.
intersection with segment DE.
BE?
No, DE.
DE.
Yes,
Thank
sir.
you. Segment DE. Just the intersection of two segments. Let's investigate that one. Maybe I haven't got another color. BC, starting at B, stopping at C, along with DE. Ooh, is that intersection?
Mr. Dickey, would you mind using another color?
Oh,
That
what
one
is
is
it?
hard to see.
What's on BC, from B to C, that's also on from D to E? I don't think there's anything that's on both of them. So what we ought to do is indicate that there is no intersection between these, and we'll call that the empty set or the null set, written like that. Not even zero, I like to think to myself. That's a silly way to think about it, but there is no intersection between those two sets. Are there more?
Yep, we have one more.
Tell me about it.
Ray AC,
Yes, sir.
intersection with segment DE.
DE. Segment DE. Not the ray,
Yes,
the
segment. Yes, sir.
Thank you. AC starts at A, goes through C, keeps on going forever in that direction. Intersect with DE, which starts at D and stops at E. And since this is an intersection, I have to think, what's on this that's also on that set? And the thing that's on both of them is the part from here to here. I'll call that segment DE. And I should answer it just like this. Maybe even neater. But there will be the intersection of those. Kind of simple on just along the line, but maybe it'll get more interesting. Let's play some more. You can probably just swivel over here, right?
Here we go.
I think the first question, here we have line AD intersecting line HE intersecting line FI. So a little bit more interesting. Let's play, see what happens there. What's the first question, please?
We have Ray BE,
Ray BE,
union with Ray BC.
union Ray BC. Now let me think. BE, the ray, starts at B, goes through E, keeps on going, joined together with BC that starts at B and goes through C and keeps on going. I have this ray and that ray. They make an angle, don't they? Now, how do we write an angle? The simplest way you would hope. We'll show an angle, make a little angle picture, and we're talking about the angle with this ray and that ray. We're talking about angle EBD. I wonder if I could have named it differently. And yeah, I could have. It could have been called ray G, angle GBC or GBD. Just a point from here to the vertex. The vertex will always be in the center as we name an angle to one of those 2 points. I'm happy with naming ray angle EBD. Hey, what's the next question?
I have one quick question, Mr. Dickey.
Yes, sir.
Could I go the other way and say,
Oh, absolutely. Would it be okay to call that angle DBE? Is that what you're thinking?
that's what I was thinking.
Just as good, not even any different. Same idea. Thank you. That's a good point.
Gotcha.
Tell me all those thoughts that come to mind. What more?
Let's see, next we have Ray FG,
FG
intersection with segment AD.
intersected with segment A who?
AD.
AD. Segment AD. So we have to think the ray that starts at F, goes through G, keeps on going all the way through here, infinitely long, intersect with AD that starts here and stops there. What's on this ray that's also on this segment? And it's just going to be that point. Now, how do I name a point? You don't really have to put a point there. In fact, it's not even a great idea. But we just want to name that point. And if we just put a single capital letter, we've talked about point C. There it is right there. The intersection of ray FG and segment AD is point C. A point would not be necessary. What's next? Let's do more. This is gonna get more and more fun, I think.
We have segment DA,
DA,
intersection with line EH.
EH. Line EH. So now this is an intersection. We're not joining them together. We're saying what's in this that's also in that. And line DA, starting at D, going through A, no, just the segment from D to A, just the segment. What's on that segment that's also on line EH? What's on this segment that's also on this line EH? It's gonna be just that point B again. So I'll name that point B. Tell me more.
Let's see, we have ray CF,
CF,
union with ray GI.
GI. Both of those are rays?
Both of those are rays, yes, sir.
Okay, CF, where's it start? Starts at C, where's it go? Goes through F and keeps on going. Got to put that together with GI, which starts at G and goes through I, keeps on going. These are collinear rays along the same line. I want the thing that starts here and goes that direction, intersected with the thing that starts here and goes that direction. It seems the thing that would be common to both would be this amount right there, from G to C. Or could I call it from C to G? I think either way would be fine. I'm going to call it GC. GC, just the segment. GC must be in this ray, and it must be in this ray, and I'm saying that it is. Would have been fine to call that CG just as well.
Oh, Mr. Dickey, why
Yes,
didn't you
dear.
put any arrows on it? Why didn't you put any arrows above GC?
Oh, I certainly should have put arrows on it, huh? CF, let me look at this again. CF, and yes, I should have put arrows on it because we're unioning these things that go infinitely long in both directions. So I think this would have been an okay answer for the intersection perhaps, but I think it's certainly the right answer here better be the union must be the full line. As you pointed out, thank you. That's why I need you.
All right, we got segment CG,
CG,
union with ray GF.
GF, the ray. I gotta think to myself, what's on CG, starts on C, stops at G, put together with GF. The ray from G to F. Oh, the segment from C to G together, joined together with the ray from G through F. It looks like I'll have something that starts here, goes to G, and then keeps on going through F forever. I should name that ray. It'll be a ray that starts at C. It'll be a ray out, that's for sure. Now I gotta start at C, and I know I'm going in this direction. I think it would be okay to call it ray CG or to call it ray CF. Myself, I kind of like using the outside points, but you could call it CG and it would be just as good. I'm gonna call it CF. Two names for the same ray. Do we got more on that same section?
We have one more.
Yes, ma'am, what were you thinking?
Could we put 3 letters underneath, put all 3 of
Wouldn't
them
that be clever? Let's think
CGF?
about that. If I could think, might call it CGF, ray CGF. Wouldn't be necessary though, would it? Because we know this guy's gonna start at C and go through G. It's gonna start at C, also go through F. So that would be more than we need to do. In fact, we ought to only use 2 points, as you know.
So could I call it ray CG?
Yes, you could call it ray C. Would have been just as good to call it CG.
Gotcha.
That would
Cool.
be perfect. Is there one more?
Yeah, we got an interesting one. We have segment BC,
BC, the segment.
union with segment CG,
CG, the segment.
union again with segment GB.
GB. So now I'm unioning these things. I'm joining this set together with this set together with this set. I need to put this segment together with this segment together with this one. Seems I've got the triangle.
And that last segment is a line segment,
It's a
yes.
segment, isn't it? Thank you very much, sir. So when I put these 3 segments together, I got a triangle. So I got to think to myself, how do you get a name a triangle? That's a pretty good idea. We'll just make a triangle right there. That's what we'll always do whenever we name a triangle. And I can name that triangle using those 3, I must use those 3 vertices. I could call it triangle BCG or GCB, but I'm going to call it CBG. That would work just as well. CBG. We name a triangle by its 3 vertices in any order, not important which order at this point. until we start naming things in perfect order. But for right now, this is perfect. Is that enough of that exercise?
Beautiful.
Let's go to
Yes.
the last one. Now, this is where it gets a little more interesting, everybody. This is to represent a couple of intersecting planes in space. You might want to think, sort of like a couple of planes crossing like this. And when they cross each other, they do have a line, don't they? Could you gaze up to the top of the classroom across here?
Mm-hmm.
Here we have a plane that is the ceiling plane, and here we have a plane that is the wall plane. And I'm wondering about the intersection of those two. What's on the ceiling that's also on the wall, and it has to be this line across here. In fact, I would tell you, the intersection of two planes, if they intersect, is always a line. When we study plane 1, this what appears to be a horizontal plane, and plane 2, what appears to be this vertical plane, what is the line where those two things cross each other? First, I should write that question. Plane 1 intersect plane 2. I know if they're not parallel, if they do intersect, their intersection must be a line. I've got to figure out what line it is. And the intersection of these two planes, I think, is this line across here. I'm going to call it line AG. I could have named it differently. You name a line from any 2 points on the line. Would have been okay to call it line AB. Tell me another question.
What is the intersection of two planes? We've got that. Let's do ray AB union with ray AF.
Ray AB. Union joined together with ray AF. Looks like I got the union of two non-collinear rays with a common endpoint. Looks like I got an angle. The ray that starts at A, goes through B, keeps on going. Join that together with the ray that starts at A, goes through F, and keeps on going. I have an angle. I remember how to name an angle with a little angle marker. And then I want to put the vertex A in the middle. I could call that angle BAF perfectly fine. Are there other ways you can name it? Sure. You could call it GAF or even FAB. I think that would work. I'm going to call it angle BAF. Tell me another question.
Mr. Dickey, I'm
Yes,
kind
ma'am.
of confused. Why is that ray from A to F? Why is it not continued? Why is the
Why don't we
the
see it
ray-
here? Why
Yes,
doesn't it show
can't I
there?
see it?
Well, it's hidden beneath plane 1, and that's why we can't see it. Yeah. That's an interesting thought about a three-dimensional figure in two spaces. Makes us have to think a little harder. Give me the third question if there is one.
There is. Can we find 3 collinear points and name them?
In plane 1 or plane 2?
Any plane.
Name 3 collinear points. What does it mean to be collinear? Points are said to be collinear if and only if they lie on the same line. I can find 3 collinear points. A, B, and G. A, B, and G are 3 collinear points. I could do it that way. A, comma, B, comma, G. However, I think I see another set as well. 3 collinear points. How about C, I, and H? Would have been just as good. Is there more?
Yes. Can we find 4 coplanar points?
And if collinear means points that are on the same plane, coplanar must mean points that are on the same plane, on the same flat surface. I want 4 of them on the same flat surface. I think I can do that. Let's look at 4 points that all lie in plane 1. I'll list them here. 4 coplanar points that lie in plane 1. That could be E, A, B, and G. They all lie in plane 1. E, A, B, and G. Ms. Legate, tell me another set of 4 coplanar points. This is in plane 1. You got one that you can do in plane 2?
Okay. On 2, I see C,
Uh-huh.
B,
C,
B,
B. I'm listening.
A, F.
Certainly so. Here we have 4 coplanar points, and they all live in plane 2, huh? The vertical plane. C is in it, B is in it, A is in it, and F is in it. Yeah.
We're going to talk about that one.
We may have to talk about that point.
Yeah. Next we got line HC
Line HC,
intersecting with I.
line HC, intersect plane 1, I think that is.
I think that is a plane 1.
There you go. I can see why you might have thought it was this guy, but I meant for it to be plane one. And line HC, this line, intersects plane two at just point C, intersects plane one at this place right there, huh? If a line intersects a plane, it does so at a single point. And I say that the intersection of this line, CH is it, or HC, intersects plane one at just point I. I don't need to put a point there, I just gotta put an I there. That's a little confusing, I would understand. This I represents plane one, and this I represents that point right there. So, not perfect, but I think the understanding is there. Is there a little bit more?
Oh, yeah. So let's talk about that point G we were thinking
What
about earlier.
that point G?
And let me zoom
The
in on
question
it.
is point G in plane one, or is point G in plane two?
And explain.
And then we gotta explain why we think so. A little while ago, we agreed that the intersection of the two planes was line AG. And if that is the intersection, that means that line AG exists in plane one and in plane two. Therefore, I gotta tell you, although it is not obvious, that point G is also in plane two. You might say it doesn't look that way to me. It looks like it's outside of plane two. But actually, when we think about a plane, it is infinite. It doesn't have corners. When I make the sketch of them, it's got corners, but planes don't have corners, they are infinite. And plane two continues, and G is also part of plane two. I say again, if line AG is the intersection of plane one and plane two, line AG must exist in both of them, therefore G must exist in plane one, and G must exist in plane two. Is that all of that?
Beautiful, that is it.
Thank you very much. Now, guys, what you ought to do is go to Canvas, find the exercise that's like it, and work that through. And when you take a picture and turn it in at Canvas, you're going to do a really careful job, work it through carefully and neatly. If you don't have a copy machine, you don't need to make a copy, but you can make a sketch, put it flat on the table, put your camera above it, and take a picture filling your screen with just your work. That's all I want to see. Take that and send that picture to me at Canvas, and I can get a good look at it and do a good job of grading it. Thank you very much. Good morning.